I am Jagadeeswari, K.Sc College of Arts and Sciences for Women, Department of ADS, Fundamentals of Data Science. The need for data science and its benefits. Data science has become essential in today's data-driven world for several compelling reasons. Why we need for data science? Helps organizations make sense of vast amounts of data, enables data-driven design making rather than intuition-based choices, identifies patterns and trends that humans might miss. Key benefits: improved operational efficiency and cost reductions, better customer understanding and personalized expenses, risk mitigation those predictive analysis, new revenue opportunity through data monetizations, competitive advantages in evolving markets, real world applications, health, hair diseases and then treatment optimizations, finance, detection and risk assignments, retail, inventory management and customers behavior analysis. Facts of data and the data science process. Types of data structures organized in database with clear files. Example: spreadsheets. No format. Example: text, images and videos. Semi-structures contains tags or markers. Example: XML and zones. Time series sequential data points collected over time. The data science process. Problem definitions, data collections, data cleaning and preparations, exploratory analysis, modeling, evaluations and interpretations, development, deploy and communications. This process requires context refinement. A new data becomes available, business and evolve. From research goals to data analysis. Setting research goals. Clearly define business objectives and questions. Establish success criteria. Align expectations. Determine required resources and timeline. Data retrieval method. Internal databases and data warehouses. API and web scraping. Public database datasets and data markets. Surveys and direct collections. IoT devices and sensors. Data preparations. Cleaning. Handling missing values, outliers and duplicates. Integrations. Combining data from multiple sources. Transformations, converting data into usable formats. Future engineering, creating new variable for existing data. Analyzing, modeling and applications. Exploratory data analysis, statistical summaries to understand distribution. Correction and then analysis to identify relationships. Visualization techniques to recognize patterns. Building models, supervised learning, production based on labeled data, unperceived learning, finding patterns without labels, deep learning, complex pattern recognitions, time series analysis, forecasting future trends, presenting results and building applications, interactive dashboards for ongoing monitoring, automated reported system, design support tools. Implementation challenges and best practice. Common challenges: data quality and accessibility issues, privacy, concurrence and compliance, talent storage and skill gaps, integration with existing systems, organizational residency to data driven change. Best practices: start with clear business objectives, not just the data. Build cross-functional teams with diverse expressions. Implement data governance frameworks. Create a culture of data. Focus on evaluate and improve models. And the next topic: frequency distributions and the types. Frequency distributions organize data and categories, showing how often each value assumes. They help us identify patterns in large data sets. Types of frequency distributions: simple frequency distribution, relative frequency distributions, and then formula cumulative frequency Last one, useful for determining how many observations fall below a certain value. Graphical representations and outliers. Common graphs for displaying distributions. Histograms display continuous data in equal with intervals. Bar charts display frequencies for nominal data. Line graphs show frequency trends, especially useful for cumulative distributions. Outliers data points that differ between from other observations. Deduction methods visual inspections use box plots and then statistical test values and then greater than 1.5 multiple 1 QR from the quartiles. Z-score methods values with Z greater than 3. Impact of outliers can scale the mean, may distinguish statistical analysis. Called representations and errors O are important anomalies. And the next topic is measures of central tendency. Three main averages. First one is mean, arithmetic average formula, and then best for normally distributed continuous data sensitive to outliers, used for further statistical calculations. And the next point is median. Median value when data is arranged in order. For odd means n, middle positions. For even n, average of two middle position. Residence to outliers, preferred for skewed distributions. Analyzing different data types and interpretation. Handling different data types or ordinal ranked data and then interpreting distributions. Handling different data types means normal data. Use frequency distributions with bar charts. For example, analyzing most common hair color in a class. Interpreting distributions, shape, center, spread and then features. Thank you.